So my name's Lee Jones, I'm the ST Ericsson landing team lead. My main job, or my team's main job, is to upstream as much of ST Ericsson's BSP code as possible. So I'd like to get a gauge for who's sitting in front of me now. Out of you, by a show of hands, can tell me that you're a maintainer or a regular contributor to Upstream. 1, 2, 3, 4 people, that's great, thanks. Who are the would-be upstreamers amongst you? So if your manager allowed you to do it, or if you had enough, or if there was enough time in the day. Yeah, great. Who's here to find out what upstreaming is or how to do it? Even better. And who are the people amongst us here who are against upstreaming? So it's not their company policy, or they think it's a waste of time, or what have you? None of those people. Okay. So the topics we're going to briefly cover then. Repository hierarchy or repository hierarchy tree. What is a maintainer and how can they, and what do they do? The benefits of upstreaming and how to upstream your code. We're also going to cover very briefly how long it takes to upstream your code. First thing we're going to cover is repository hierarchy. So the repository hierarchy is a theoretical hierarchy of repositories. It's one repository on top of another looked after by any particular maintainer in a hierarchical view. Many of them are Git maintained now, although I'm sure that there are one or two that still use archaic versioning systems such as SVNs, CVS. Each repository specialises in one topic. There are 902 different topics or code slices throughout the Linux kernel. When I say one repository, that doesn't necessarily mean one repository to those of you who are comfortable with Git. It can mean a different branch on a repository. There is one maintainer per topic, and there are 505 unique maintainers currently registered within the Linux kernel. So here's what the hierarchy looks like. At the very top, you've got a main line. That's looked after by Linus Torvalds. I'm sure we all know who he is. Underneath that, I've picked two areas which are of particular interest to Linaro. So firstly, you have the architectures, and then we have driver subsystems. There are many more of these, but these are the two that I'm going to use as an example. So underneath mainline, directly underneath mainline, you have the architecture trees. Now these are the people that are looked after by the Russell Kings of the world. So that's the ARM repo in this particular case. You've also got things like Chris, MIPS, SuperH, and x86 under there. The Linux kernel currently supports 24 different architectures. Underneath architectures, you've got sub-architectures. So these are our four partners. So starting from left to right, you have Freescale, the nomadic architecture, which is ST Ericsson, Samsung, OMAP, and who knows, we're currently in talks with bringing on other partners along. It could be your company. So on the other side then, we have driver subsystems. So this is another route going from, travelling from mainline. Underneath driver subsystems, there are currently 90 supported. The examples I've given are particularly short and fit in the boxes I've provided. Underneath that, so a lower level down the tree to that, you have the more specific driver subsystems. So underneath ATA you have something called Promise. Underneath Base you've got Power. Underneath DMA you've got IO, and so on and so forth. I'll go into these in a little bit more detail in a second. So what is upstreaming then? If you have a developer, for instance, in my particular example, it's an STE developer, or someone like myself who works with STE, and we want to upstream our own code, we have to go through the hierarchy to the very top to mainline our code. So you have an STE developer here. He has to then go through the nomadic repo, which is maintained by Linus Bollé. He has to go through the ARM repo, which is maintained by Russell King, and to eventually end up in mainline. And that process is what we call upstreaming, moving your own code up to the Alpha 1 repo. So who are maintainers? Briefly covered a couple of them, and what do they do? So a maintainer is a subsystem code owner. Here's a person that owns any particular slice within the Linux kernel. By code slice, it could mean a subsystem or any number of files or directories, so on and so forth. They act as gatekeepers. They're the people that are going to be accepting or rejecting patches that are submitted by the developers at the lowest levels. Every maintainer within the Linux kernel, except for Linus Torvalds, also have upstreaming responsibilities. So people will try and get their code into the lowest level maintainers or the most niche maintainers, and then those maintainers take responsibility to keep upstreaming their code into the higher and higher level maintainers until it eventually reaches the Linus Torvalds. So here's what the maintainer hierarchy looks like. You'll see that it's very similar to the repo hierarchy. So at the very top you've got your level 1 maintainers. That's only Linus Torvalds. Underneath that you have your level 2 maintainers, which are the Greg KHs of the world and the Russell Kings of the world. Underneath that you've got your level 3 maintainers, which is the Linus Walays and all the people that we work with within Linaro. Then you have level 4 maintainers, and this can keep going for depending on how complex any particular code is or how niche any particular file can be down the hierarchy. So here's how they all fit in then. So right at the top you've got your alpha 1, your level 1, which is Linus Torvalds. Then you've got your level 2 maintainers and your level 3 maintainers, and this tree can go on for as long as you like. And here they all are. I'm under good advice that actually the x86 one is currently wrong, and actually that's group maintained rather than any particular person. So, if you've got your, to reiterate then, if you've got your developer who works for SD Ericsson, to upstream his code, he needs to traverse the tree up to the very top point. Once it's at the top point, that code is then considered mainlined or upstreamed. So if we look at some statistics, as I mentioned earlier, there are 505 unique maintainers within the Linux kernel. There are 902 subsystems, topics, code slices, call them what you will, currently registered within the Linux kernel. So if the developer right at the bottom of the tree wants to upstream his code, he needs to find out who he needs to first forward his code onto. Who is the lowest level maintainer that looks after the piece of code that he has changed? The answer is you have to look in Linux maintainers, or you can run a Perl script. The Linux maintainers file is a text file that contains a number of entries. This is one of those entries. I've picked Linus Wallet because he's the lowest level maintainer who I personally work with. This gives you some relevant information. The M is not the maintainer, the M is mail to. So if you touch this particular code area, code slice, subsystem, whatever you want to call it, you need to mail all these people here. You also need to mail the mailing list, which is the lowest common mailing list for that particular code area. The S is the current status of this particular maintained area or code slice. Then you've got the files in which this particular code slice touches, and then finally you've got the lowest level Git tree or the repo within that tree that this particular code area touches.
Just a comment on the maintainers file. The maintainers file is your starting point where you're looking for stuff. The data that is in here is not necessarily authoritative. It will give you guides on where to start, but if you have questions, these are people this is the starting place to go and ask and find out, okay, who am I actually supposed to be emailing, so that you're not completely off on your own to try and figure out what to do.
Yeah, I agree. Thank you. Next thing we're going to cover is the benefits of upstreaming. So what we're currently seeing is that even within our partners, a lot of management inside those need education, and they insist that upstreaming is a waste of resources. They think that it's a waste of time and has no real benefit. And after all, time in most business areas equates to money. They also think that it's a waste of engineering power. They think that their engineers, once they're finished working on their piece of code, should work on the next piece of code rather than spending that extra 5% trying to mainline their code. Now that's probably, especially if they start to reuse their code or use the same chips within their hardware, that's going to start costing them a lot of money. They also think that they're giving away work to competitors. But most of their competitors now are currently upstreaming their code, so this is really null and void. It actually helps out, so each company will spend less time on development because they can start using each other's code. So this, at the end of the day, they're saving money. So one of the first benefits that I'd like to cover is maintainability. As soon as you upstream your code and it reaches the top level, you renounce responsibility. You're no longer responsible for that piece of code. A particular maintainer will then take that responsibility on. Albeit when there's changes, he'll probably ask you to change it, but if you say no, and there are a lot of people using that code, then he's going to have to use his resources to change it and not yourselves. Don't tell him I said that. Next thing is with regards to forward porting. The Linux kernel moves at a fantastic rate and changes at an even larger rate. The APIs are constantly changing, and if your driver uses an old API and then there's a big API change, the maintainer of that particular area will, the chances are, will move that forward for you and make the corrections for you. So again, you renounce responsibility. Your code then becomes future-proof by upstreaming. So here's an example. You have a manager who's in charge of a crack team of software engineers. They create a fantastic piece of, they haven't got there yet. They create a piece of software which goes into a product which is a big success. After the release of the product, the code is then shelved. After a period of time, another senior manager comes along and says, look, that product was such a success, let's create another one. After a long period of time, the kernel has moved so far forward that your code will no longer work. So it'll either require a forward port, which will cost money, or a complete rewrite, which will cost a lot of time and money. Next thing you get is quality assurance. In the process of upstream...
There's another thing we discussed this earlier in the ORM kernel sessions.
Yeah.
When stuff goes upstream, and we see that all the time, that the IP blocks are not that different, which are used because there are not that many IP vendors out there.
Yeah,
so,
you're right, yeah.
So the chance that something which is very similar to your IP block you have to write a driver for it is already in the kernel, is rather high.
Well, that's where you step in, isn't it?
Pardon?
That's where you step in, isn't it?
Yes. So, and if stuff doesn't get upstream, then you have 5 incarnations of the same driver for the same IP block all over the place, and nobody's looking at it, and you can't share resources. Yeah. And so in the long run, having stuff consolidated, not only upstream, also consolidated upstream, is a benefit for all players, because for your next project where you reuse IP blocks, or just a different variant of the same IP block, you have a decent chance to save a lot of time. Yeah. And that's what really is.
And some managers within companies refuse to upstream because they don't want to share their code. But as you say, it's ridiculous. And even worse, when 2 IP blocks do enter the kernel and are similar, it's then that you've then got code wastage and things like that. When 2 IP blocks are upstreamed and they're very, very similar, but they're in separate sub-architectures, you then get code wastage and things like that.
Yes. So that's what we are tackling right now.
Exactly.
We're moving drivers to the place where they belong, and then we see the commonality and can fix that up.
Thank you. So within the upstream process, if you manage to get your code upstream, it would have been reviewed by at least 1 person. Now that person isn't Joe Bloggs, who sits next to you at work, who happens to be the best programmer in the room. These are the best programmers in the world that are going to review your code. If they're not maintainers themselves, then they're going to be well-known reviewers and well-respected reviewers. This will ensure that the code is programmed correctly. It will ensure that you're using the correct APIs, you're not using any hacky code or anything like that. The maintainers and the reviewers have seen many code incarnations before, and they're going to know what works best on any particular system. So this is going to ensure, as much as you can, that your code is going to be optimized as much as possible. You haven't written 3,000 lines of code that can actually be you can actually use some API and actually do that in AMI. I did put bug-free, but the Linux kernel is never going to be bug-free. It's just so massive. But many of the maintainers and the reviewers would have seen many of the bugs that your code would potentially introduce before. They can then iron those out, tell you that this could perhaps be a problem, and you can rewrite it to try and iron out those as much as possible. You get testing and validation on a massive scale. When you upstream your code into mainline, and then any company takes the mainline tree, they're going to be using your code. If they're using the same hardware, they're going to be using your code. This is particularly prevalent in common code. If you make a change to common code, thousands of people, millions of people are going to be using your code every single day. If there's a problem with it, people will let you know. You get direct user feedback via this process. This can either happen in, you can actually get these from bug reports, or people will actually scan the code, find out who wrote a particular block, and contact you directly. If not, if they know how to use Git, they can use the Git logs or Git blame to find out who wrote a particular file or a particular line in any file. And they'll contact you and say, look, there's a problem here, would you mind correcting it? And this goes back to the responsibility thing as well. If it's affecting somebody, but you're too busy to change it, you say, actually I haven't got time to fix this at the moment. And the chances are, if they're any good, they'll fix it themselves, or they'll get someone else to fix it. So you're saving time at the end of the day. So how do you upstream your code? This presentation involved a tutorial on how you should upstream your code, but it went on for far too long. I'm probably boring you already. I've ripped most of that out, but we're going to make the original presentation available. So if you are here to find out what upstreaming is and how to do it, then please download that, and it will be more of a tutorial for you than this is. Firstly, prepare your code. When you plan it, and there's bits that you don't know, there's holes that you need to fill, ask the mailing list. They're not only there to forward patches, they're there to provide advice. And if you write your question in an eloquent manner, and you're polite and you seem knowledgeable, you seem like you want to learn, people will want to help you. They will reply to your email and they will give you nice, sensible, eloquent answers. Author the code, but before you do, please read the documentation. Have a look through Linux documentation. There's loads of stuff there which will cover the processes that you're going to use, the APIs that you're going to come across, and the styles and advice are there too. So read coding style, it will tell you how you need to start to author your patch. Then create the patches. You can either do this by, if you're using archaic versions or you've downloaded a tarball, you've made a change that you want to see upstream, you can use diff. I suggest you use git format patch, however. To be a good kernel engineer, I really strongly feel like you should learn Git and become very, very apt with Git. Create your patches as logical groups of functionality. Don't be tempted, just because all these different files are in one particular directory, to group them all together, because the chances are that particular commit won't compile without the next commit in the tree. So each commit has to be individually compilable. If a revert happens, because a large chunk of code above you needs a revert, and they've reverted back to one of your commits, that commit, doesn't matter where it is in your patch set, has to be able to compile separately. Keep upstreaming going in with small patches, so small patch sets and small patches, and keep upstreaming them often. This will help you in multiple ways. Firstly, they're easy to understand and review. No one really likes to review massive patch sets or massive patches. People like to review small stuff that they can understand easily and see if it works. So split your code up into smaller blocks, if that's at all possible. It makes the if someone comes back to you and rejects your patch, it makes the changes very much easier. So if someone rejects an entire driver, you've then got to rewrite that entire driver. Or if not rewrite it, then make a change and submit the entire driver. If you're doing it patch by patch or small patch set by small patch set, you can make the amendments and then resubmit. This also identifies fundamental problems very, very early. So if you've started using the wrong APIs or dated APIs, you'll be told about that very, very soon. If you've written an entire driver based on old APIs and you try and upstream it and they say you need to change that, that's an entire rewrite then. That will cost you so much, that will cost you a lot of money and time. Ensure you go through the review process. Firstly, ensure that your patches compile on the latest kernel. The amount of times I see Greg KH replying and saying this doesn't compile on my kernel starts to get a little bit silly. If you're upstreaming, your code needs to work on the highest level repo. Use that repo, compile against that repo, then send your patches. Test the functionality. Just because it compiles correctly, it doesn't necessarily mean it's going to work. Run it on your hardware, run it on the boards, ensure that your change or your new functionality works the way that you want it to work before you upstream it. Run check patch on it. This will ensure that there are no white space errors and none of your code goes over the 80 character boundary, things like that, and lots of other things in between. Send them to your internal mailing lists first. You might have some local experts which can help you before you finally reach the public domain. Once you've reached the public domain and you're still making amateurish errors and you're continually being told about fixing your amateurish errors which local people could help you with, then people will be less inclined to want to help you. Once complete, as you signed off by it won't be accepted upstream unless you've signed it off yourself. And and don't sign it off if you're not comfortable, confident with your own code. And then don't upstream it. Then submit it. So before you submit, read these pieces of documentation. Submit checklist and submitting patches. They will tell you about all the common pitfalls that people come across and how to rectify them. And you can, if you rectify 90% of your own issues, you're only burdening the mailing list with 10%. Then you need to locate the email destination. I've briefly covered Linux maintainers. Please have a look through there. Find out who was supposed to be maintaining it last. Ask them questions. Then run git maintainer. That will churn out information such as, here we go, the maintainer's emailing list and the mailing list addresses that you need to forward your patches onto. Also, don't forget to include any interested parties. So if you've made a version 1 patch set, then and someone's commented on that, they're obviously interested in what you're doing. They might have some interesting information for your version 2. So don't forget to CC them, because they might miss it on the mailing list the next time, and you might miss out on valuable information. Lastly, always CC the LK owner. And there's the address there. So sending your patches then. I suggest you use git send email. It irons out a lot of the problems that we see with regards to email client specific stuff. You can use your email client, by all means, go ahead. If you do, then ensure that you read this text file first. There are a lot of default settings and a lot of email clients which don't really match up very well with the way maintainers and reviewers like to see patches.
Wouldn't you suggest to send the email to yourself first and see whether you can...
Absolutely, yeah, I do. And that's what I do every time. So I use git send email, but send it to myself the very first time and nobody else. That way I can see how it's going to appear on the mailing list, and I can often identify some of the problems occur. Cheers, Lloyd. Okay, so you can either send patches via a single patch or a patch set. If you send them via a single patch, these are the way that you'll find them on the mailing lists. So you've got, I'm not saying that this description is fantastic, so don't use this as an example, but a good one-line short description of what the patch is going to do, but right at the, prepended on the subject within square brackets, uppercase the word patch. Both reviewers and maintainers then know that you're trying to upstream code, and it's also used for mailing list parsers. This is a patch set. So patch sets, even if you don't really care about the order, please place them in order. As I said, no lower commit should rely on an upper level commit, so they have to be ordered. So order that within these square brackets. When you upstreaming patch set, you also add a 0 of 3. That will give a better description of what the entire patch set is trying to do. This won't find its way into the history. This is more for the reviewers and to try and get an idea of exactly what it is you're trying to accomplish. Dealing with the mailing list then. This can be an art in itself. You may be your best kernel engineer in the world, but be harsh and abrupt and people won't want to listen to you. First of all, be patient. The mailing lists are extremely busy. Your patch may not be reviewed the first day or the first hour that you place it up. It might take a good few days or a week or so. Bear with it. After a couple of weeks or a week or so, if no one said anything, but you need this patch reviewed, give them a nudge. But don't send them emails every hour saying you still haven't done it, you still haven't, because they'll just delete it or be more inclined to ignore it. Be polite and don't take offence by what people say. Some maintainers are well known to be very hard to work with. They're straight talking, non-diplomatic. They're very busy people. They have very little time on their hands to fluff out emails and say, oh yeah, you did this wonderfully. They'll just come along, chop your email up, and say, chop your patch up and say, this is wrong because of this, this is wrong because of this, and then probably give you a bit of a hard time as well. So well, shrug it off. Explain your reasons for decisions. Maintainers aren't always right. Normally, don't get me wrong, they're fairly correct, but they might have the wrong end of the stick of what it is you're trying to do. Especially if you've spoken to another maintainer who actually says, you know, this is a good idea because of this, that and the other, or you've taken heed of advice prior. Link that email, or say, actually, this person said this because of this, and I'm trying to, you know, explain what it is you're trying to do. And if they say, no, it's still not correct, then you need to go away and probably make some changes. If you don't understand, ask. He who asks a question is a fool for a minute, he who does not remains a fool forever.
One thing I noticed, you're totally right, there are maintainers who are hard to work with. They are not always polite, but most of them actually are polite when they start reviewing a patch.
Yeah.
When they start to be really grumpy, if they explained, oh, you shouldn't do that because A, B, C, and then the person runs away and posts a patch which actually ignores that again. So that's the way you really can make people upset, because you're wasting their time. So another thing is, what maintainers often do is, something like, you might look into X. There is something similar. Look how it's done and do it. And look whether it applies to your problem as well. It might. So then people go away and rewrite the whole code so it looked like X, even if it gets worse than it was before. So this is the kind of thing you should never do, because that really makes maintainers grumpy. So then, then those people are viewed as those grumpy old farts on the Linux kernel mailing list. I'm one of them.
I wasn't going to say anything, Thomas. I wasn't going to name any names.
You can do that. I'm well aware of it. But usually I help out people and try to work with them. But when I have the feeling I'm wasting my time, and time is really limited. So the bandwidth we are having, high volume maintainers are having for review, is extremely limited.
Yeah, I agree.
And so we rather work with people where we get good feedback than wasting our time on reviewing the same crap over and over and people not listening.
Yeah.
I mean, I'm perfectly fine saying, yes, I was wrong in public, so there's enough evidence out there. So I don't mind having a good technical discussion about the problem, and then step back and say, yes, you're right, you have to do it this way because it doesn't fit. That's not a deal. Most maintainers can do that.
Yeah.
But getting a no reaction, that's what really heats up the thing, and up to the point where maintainers simply say, go away.
Definitely need to take heed of what they're saying. Try. That's another thing. Try not to pee off maintainers. Okay, so get inflamed. Christoph said my code is buggy, my office smells, and my hair looks strange. He said it on Linux kernel, and everybody saw it. First of all, congratulations. You've just managed to gain the attention of one of the best programmers in the world. Take all those comments out, throw them away, ignore them. In between each one of those comments, there was probably a reason why your code was buggy. Probably a good reason for it. So take his advice, take heed, go and rewrite the patch, and then resubmit, and forget that he ever said your hair looks strange. And then perhaps go and get a haircut. Then make your changes and resubmit. Your patches, unless you're very, very good at this and are no, even if you're very, very good at this, I'll take that back. Even maintainers via high-level maintainers get code chucked back at them and say, look, you need to change this, you need to change this. The maintainer I work with, Linus 8, is an excellent kernel engineer, but people do make mistakes, and he does get picked up on things, but he just goes away, makes a change, and then upstreams it again. No biggie. He doesn't get discouraged, and neither should you. Here are some typical reasons for change requests. You'll find this in the documentation that I've mentioned before, so I'm not going to elaborate on those anymore. If you want to use this as more of a tutorial, then please go back and find that. So how long does upstreaming normally take? The real answer is how long is a piece of stream, but there are various factors which will either lengthen or shorten the upstreaming process. The first one is if you get your code correct the first time, then obviously the upstreaming process can be very, very short. If you've got to make corrections and there's a lot to be changed, then obviously that's going to take some time. If the complexity of the change is at an extremely high level, you need to go away and read some documentation or find out how another sub-architecture works, or someone said, like Thomas said, someone said this is very similar, why don't you use this as an example kind of thing. It's going to take a little bit longer. The merge window can also make a massive difference. For those of you who don't know what a merge window is, here are some stats about it. It lasts about 8 to 10 weeks and is open for about 2 weeks. So what happens is, within the kernel release cycle, a kernel is released. We'll say 2638 is released. So then the 2639 merge window will open for 2 weeks. Within that 2 weeks, all new functionality will be pulled from the level 2 maintainers into mainline by Linus. After the merge window has closed, no new functionality will enter until the next merge window. Release candidate 1 will open, and that will be a very buggy, probably won't even compile kernel. After succession through the release candidates, the kernel will get better and better, and eventually by RC8, the kernel will be fully compilable and almost fully working. After RC8, the next release will be released, so we'll say 2639. Then the 2640 merge window will open, and so on and so forth. Okay, does that make sense? Please.
This isn't, are you going to talk about Linux next?
No.
Okay, we need to talk about Linux next. This isn't entirely true when you're talking about upstream code and what you need to be targeting for. Yes, this is what we work with, and this is the development cycle that the Linux kernel releases work on. That merge window, when that merge window opens, this is the time for Linus and the maintainers that he deals with to talk back and forth. When you're getting stuff upstream, what your goal has to be is not to get your stuff into the merge window, but to get your stuff out onto the mailing list 3 or 4 weeks before the merge window, because that's the time that the maintainers are going to be looking at stuff and deciding what to pick up and put into their trees. And then what goes into their trees, there's an integration tree called Linux Next. Now Linux Next is a tree that's rebuilt every single day. Well, every weekday that Stephen Rothfeld is working. He maintains Linux Next. What he does is he takes all the sub-maintainer trees and he does a trial integration. And then he builds it and he releases it after testing and booting on some hardware. So your goal as a Linux developer who wants to upstream your code is to get your code into your sub-maintainer's tree, which will go into Linux Next, and we'll get some of that initial integration testing before Linus even looks at it. Then, when the merge window opens, in fact, the merge window isn't nearly the chaotic time that it used to be, because most of these patches have already been tested, they already work, and we've got fairly nice RC ones now that compile and work on real hardware.
They're certainly better than they used to be, I agree.
It's a lot better, and Linux Next has made all the difference in the world. So, your target is Linux Next. And remember that. Once you're in Linux Next, there's a good chance you're going to just go into mainline. And if there's problems caught in Linux Next, you'll know about it early before you get an angry email from Linus saying, you broke my kernel.
Yeah, I agree. Okay. So, just to re-emphasise really, in fact this is null and void with what you just said. For your, it's not really actually, for your, once your code reaches the level 2 maintainer level, you're then waiting for the merge window open before you actually appear in Linux mainline. That's kind of the point I was trying to make. Also the depth of the maintainer hierarchy, where you actually enter. So here's the maintainer hierarchy again. If you're issuing code at the very, very bottom level, say even the level 6 of the maintainer hierarchy tree, your patches have then got to go through 4 different upstreaming, whatever you want to call it, I can't think of the word right now. There are patches sitting at each one of these, and each maintainer will have his own queue. So the patches will have to go through the 4th level maintainer, the 3rd level maintainer, and the lower down that tree you enter, obviously, the longer it's going to take for your code to finally reach mainline.
But the percolation from a maintainer upstream to the second tier is usually way faster than what it takes to review and integrate the patches.
Yeah. So the first to get your patch within the first maintainer's tree will take the longest amount of time. After that, the process does speed up.
That's due to Git, because we are very effective now with aggregating stuff in one tree, then sending pull requests to the next level maintainer. And Linus had a very strict policy about merges earlier when we started working with Git. He didn't want to see merges, but then he noticed that it holds up the process a lot. So he loosened the rules on that, so we can actually push things up into Linux Next very fast.
Yeah.
In fact, if you go back a slide, what you'll see, and that you don't need to do, this is some extra information, you don't need to worry too much about this, but we'll have situations where 2 subsystems will depend on the same code. And in that case, the subsystem maintainers will talk and they'll go, okay, well, here's this base set of patches that we both depend on, we'll both pull that in. It's the same commits. Git does this, it takes care of all this stuff for us. So it all shows up as one commit in mainline, but 2 subsystems maintainers can have the same code in their tree.
Yeah,
and percolate up normally.
and that's actually something you should be aware about. If you trip over something which has a shortcoming in some infrastructure, in some generic code,
Don't be afraid.
not work around that shortcoming in your code.
Don't
That's
be afraid.
going to be fired back. So what the right thing is, talk to the relevant maintainer, even if it's a totally different subsystem, and then it gets fixed in the generic infrastructure, or you send a patch against the generic infrastructure. Now we have the problem that your code depends on it. We solved it that way. I take, for example, if it's timers or interrupts or whatever, I take the change, separate it into a separate branch in Git, and ask the other subsystem maintainer where your larger patch goes in to just pull it.
Mm-hmm.
So then it doesn't matter whether I move that patch first into Linux 3 during the merge window or the other guy, because it's the same commit and it just doesn't show up.
Yeah. This is probably a little bit more in-depth and complex than I intended
but,
to.
But one of the problems we see, especially in ARM, is that people are reluctant to do modifications to the frameworks for whatever reason.
It's normally quite a lot of work.
No, actually what happens if you talk to those guys and not work around, I just recently had a patch where I saw it and said, no, you don't want to do that. I do that in a cool code for you in 3 lines, and it removed 500 plus lines from the driver.
Yeah, I agree. Yeah, that's the point I was trying to make.
One of the reasons is a lot of people who are new to that came over from other operating systems where it's the only way to do it.
Mm-hmm.
Because if you look into a black box proprietary operating system where you may look into the code, but you don't have a chance to modify the code, then the only thing you can do is work around in your driver.
Yeah.
So people should learn that working around in the driver is almost always the wrong approach.
Yeah, there's a document in the documentation directory called stable API nonsense. One of the things that internal to the kernel, for a very purposeful reason, we don't have a stable API. Because core internal kernel stuff, we want to change, we want to fix bugs. We want to adjust the APIs as need be. External, the user space interface, that's locked down, but internal, if you need to change something, send a patch to propose it.
Can you forward me which document that is, and I'll make sure that it ends up on the...
Yes.
Stable API nonsense text.
Yeah.
I think we're running out of time.
I'll put it on
should
our
move on. If you could, that'd be appreciated. So the final factor that you need to take into consideration is how you're perceived on the mailing list. If you've either been very rude, or as Thomas says, you've not heeded any information that was given to you, then people are going to be less inclined to want to help you, and your patches are going to be sitting on the mailing list for that much longer, awaiting review. Whoops. Might as well bring it all up then. So, to conclude then, proprietary code is always worth upstreaming. The benefits far outweigh the cons that were mentioned earlier, that were and the beliefs by normally middle management we have the problems with. Upstream your code little and often. This aids in constant world-class reviews. It avoids large rewrites, and that enjoy the process shouldn't be there. Act professional and knowledgeable on the mailing lists. Make people want to help you. And finally, enjoy the process. Does anybody have any questions? I believe we have 2 minutes.
So how does Linaro kernel fit into this hierarchy?
How does it fit in? It's kind of not in the... It's a... Right here. So first of all, we've got mainline, and then ARM. So Linaro would fit on the same level as a sub-architecture. In fact, it normally fits, on the same level as sub-architecture. So when I or someone else forwards a patch to the nomadic tree, that will then be copied over to Linaro, so it will support the same code. It also acts as more of a Linux Next as well. So Nico will take in patches that aren't yet upstreamed. So it's kind of what will the Linux kernel look like in X amount of months once this particular functionality reaches. So Nico takes in all of the patches from our 4 partners, so Freescale, ST Ericsson, Samsung and TI, and encompass all those patches in there as well. So it's Linus's mainline kernel plus all of the patches from those partners that haven't yet made it up into mainline. Does that answer your question? Are there any more? Please.
Who is the right, maintainer if the patch set is belong to,
Who is the maintainer of what, sorry?
Who is the right maintainer if the patch set is belong to, different subs?
I don't really understand the question. If you've written a piece of code that touches many directories or source files, you can have a look for those directories and source files within the maintainer's text file, or you can run get maintainer, and that will tell you who each of the maintainers are that your code has touched.
So does that mean, the lower level of, the maintainer has to contact each of the maintainer for the, for the same solution?
Usually, but I think I know what you mean. So you have a patch which changes infrastructure, which then has to fix up a lot of uses of the infrastructure. So that the thing is, you usually post the change to the infrastructure to the maintainer of the subsystem, then have the fix-ups. If it's just a little bit, there's no need to CC every of the file maintainers. That's only relevant when you have rather intrusive semantic changes.
Yeah.
So that if you just add some flag thing which has to be fixed in all those implementations, it's basically not changing.
That's probably the job of the high-level maintainer, isn't it?
Yes.
So if you make a change that affects one particular area, then it will be the high-level maintainer's role to tell all of his subordinate maintainers that there has been this change, and they should make that. That's kind of the API changes.
Yeah, and now I'll follow up on that. If you're making incompatible changes, if you change something, you change a function call, and it breaks all the other drivers, your patch isn't going to get accepted.
No, you have to fix
Yeah,
it.
fix it up.
You fix them too.
But
Yeah.
but there's no need to CC everyone in the hell on that, because usually these API changes should be discussed before you do that. So you say, here's my problem, here's the shortcoming I detected, here is my proposed solution to change the interface.
Yeah.
And then when the relevant maintainer says, okay, go ahead, then you send the patch series which changes the interface and fixes up all users.
So that's what I was saying about responsibility as well. So once you've uploaded your code, it's not your responsibility to make all the API changes. They'll be done for you. So you can. Whereas if you kept that piece of code that's had this API change in your own file system rotting away, then it is your responsibility to change that, because your code will no longer work with Upstream.
Right.
Quick question: if you pushed a patch upstream for a certain driver, and then the kernel moves to the next 1 or 2 versions, and the API changes or something,
Then the person who changes the API has the responsibility to fix it.
Exactly.
So we now have tools and things where we can do rather large scale API fix-ups across the tree, totally scripted. So Coccinelle, that's a semantic patcher. We use it a lot for this kind of work. So we had I think the largest thing what was ever done was adding an argument to one of the memory allocator things. So we just added an argument to the function, and we fixed up every caller of that function in the tree by setting the argument to some default thing. So that's, if you change anything on an interface in the kernel, then the guy who changes it needs to fix the fallout.
Yeah, I agree.
So there are 2 ways how we do that. One is either if it's not possible to do a full rollover in one go, then we usually provide a new interface, deprecate the old one, and ask people to help us fixing it. Or if that's not happening, then after a grace period, we just fix it and break stuff. So it's twofold. So if people do not, if we talk to people and say, here, we changed this interface, we can't do it full force right now for various reasons, but please look at your code, do the necessary changes yourself, and then if this doesn't happen for 6 months, then we just break it. So the don't break it rule is not always true, but most of the time.
There are no hard rules.
No.
There's really strong guidelines, but sometimes we just have to move forward.
Yes. That what happened in the last merge window with the generic interrupt infrastructure, where I had to remove all the old interfaces, and people were ignoring me for years. So I just went through and fixed them all. I mean, I broke a few.
Is there any final questions before we end it? If you do have any more questions, feel free to email me. As I said before, my name's Lee Jones. Lee.jones@linaro.org. I'll be happy to answer.
Or catch one of the upstream maintainers who are
Yeah.
hanging out here.
Yeah.
Even better, yeah.
Are your slides online?
They will be. We're going to make the video's going to be online with a lot of editing, and probably both sets. So this set will be online, and the set that goes into a lot more detail will be online as well. All right. Cheers, guys.
Thank you.